Power of a power. So it says simplify each expression, write your answer in exponential notation. So we don't have to find the value of anything, we just have to write our final answer with a base and an exponent. So when I look at number 1, it says, let's just focus in on the numerator. 4 squared times 4 to the 7th times 4 to the, we know that there's that 1 there. So when we multiply, always say to yourself, when you multiply like bases, you add exponents. So in the numerator, we would keep the base 4, and we would add 2 plus 7 plus 1 gives me 4 to the 10th, divided by it, and then do the same thing with the denominator. So we have 4 to the 3rd times 4 to the 1st times 4 to the 4th. Keep that base. They're all the same bases of 4. And then we have 3 plus 1 plus 4, which gives us 8. Now we can use our other property of exponents. If we have like bases, what do we do with the exponents when we divide? You subtract. So we keep that base of 4, and then we say 10 minus 8, 2. There's your answer in exponential notation. Okay. So number 2, we're just changing it up slightly, but we're throwing in some fractions in there, but the rules still stay the same. We have like bases, which is 1/4, so let's focus in on the numerator. 1/4 to the 3rd times 1/4 to the 1st times 1/4 squared. Keep the base 1/4 and add those exponents up, and we end up with a 5. Do the same thing with the denominator. 4 to the 1st times 4 to the 1st times 4 to the 1st. And I shouldn't say 4 to the 1st, I should say 1/4 to the 1st, 1/4 to the 1st, 1/4 to the 1st. Misspoke there. Like bases, add your exponents. So we have 1/4 to the 3rd power. Now, use that rule. When you have like bases and you're dividing, what do you do with exponents? Keep the base and subtract the exponents. So that's 1/4 squared. Number 3, same idea, but now we're throwing in some coefficients. We're throwing in some whole numbers. So let's take care of the numerator again. Let's focus in on the top. So we have 3 times 5 times 6. 3 times 5 times 6. You can use your calculator if you need to. It's 90. And then when you look, we have x to the 4th times y to the 3rd times x to the 6th. So you got to keep in mind, only like bases, x to the 4th and x to the 6th. So that leaves me with x to the 10th. And we don't have anything to multiply that y to the 3rd with, so he just kind of comes along for the ride. Y to the 3rd. Denominator, do the same thing. 2 times 3 times 5, which is 30. Now do the same exact thing with the x's and the y's. Let's focus in on the x's. So we have x squared. Are there any other x's? There aren't. So it just stays x squared. And now let's examine the y's. We've got a y to the 1st and y to the 3rd. That gives me y to the 4th. But we're not done, because now we have a division problem that we need to finish it up. So we take those two whole numbers. What's 90 divided by 30? And that's 3. And then take the x's, because those are our like bases. X to the 10th divided by x squared. And you divide, subtract exponents. Always say those rules over in your head. Gives me x to the 8th. And then the y's, We've got y to the third divided by y to the fourth. And really that would be y to the negative 1, but we haven't talked about negative exponents yet. So I always say, where are the y's left over? You've got y to the third on top and y to the fourth on the bottom. Where is that y left over? If we leave it on the bottom, we can keep it a positive exponent. Okay, so y to the first. There's our final answer. Okay. So, looking at number 4, it says, what does 2 to the 4th to the 3rd mean? So, 2 to the 4th to the 3rd means 2 times 2 times 2, 2 times 2 times 2, 2 times 2 times 2 times 2. Okay, it means 3 groups of 2 to the 4th. So what do we do when we have one big multiplication problem all along? That's all we have to do is add those exponents, and they all have an exponent of 1. So what is our base? Our base is 2, and we have, if you count all those up, 2 to the 12th. So there's got to be a shortcut somewhere in here to determine what that is. So now let's put a letter in there and we say n squared to the 5th. What does that mean? It means n times itself 5 groups. And we have all of that as multiplication. And again, what do we do when we multiply? We add our exponents. So when we add those all up, we end up with n to the 10th. So what do you notice? Hopefully you're noticing some kind of pattern happening. If you look at those exponents back up here for 2 to the 4th to the 3rd power, and then we expanded it out and we got 2 to the 12th, and then we had n squared to the 5th power and we expanded it out and we got a 10, n to the 10th. So hopefully you're noticing that, let me put something to write here, when you have a power to a power, you keep the base and multiply the powers. Okay, so that's our shortcut instead of expanding everything out. So go ahead and turn the page. Okay. When you raise a power to a power, keep the base and multiply the exponent. So that's what we said in our own words. Okay, power to a power, keep the base, multiply the exponents. Okay, so simplify each expression, write your answer in exponential notation. So this first one should be fairly simple. Okay, 15 to the 3rd to the 9th, keep the base, power to a power, 3rd raise again to the 9th, you multiply. This next one, what's the base? -2, but we have -2 to the 5th, raised again to the 8th, a power to a power, multiply. So 5 times 8 is 40, -2 to the 40th. Number 9, keep the base, 17 times 4, 68. Okay. 10 changes it up a little bit, and so now we have, I could write this another way, 3 to the 2nd to the 5th times 7 to the 4th raised again to the 5th. So we have different bases here. a 3 and a 7, so treat them separately. So 3, 2 to the 5th, 3 to the 2nd to the 5th, multiply 2 times 5, 10 times, and now do the same thing with the 7. So your base now is 7 to the 4th to the 5th power. Multiply those. That's all we can do because 3 and 7 are not like bases. So we're done with that problem. We can't take it any further. Number 11. Remember that b has an exponent of 1. Everything inside those parentheses need to be raised to the 4th power. So if you have a to the 2nd to the 4th power, a to the 2nd to the 4th, gives you a to the 8th power. Now let's take care of the b's. B to the 1st to the 4th power gives us b to the 4th because 1 times 4 is 4. And now let's look at the c's. C to the 3rd to the 4th power. So 3 times 4 is 12. And there's your final answer for that one. Okay. Taking a look at 12, negative 4 squared times negative 4 to the 3rd power, all raised to the 6th power. Negative 4 and negative 4, those are like bases. So our base is negative 4, but let's take care of what's inside the parentheses first. When you multiply, what do you do with exponents? You add them. So the 2 and the 3 gives me negative 4 to the 5th. That was just from what was inside those brackets. And now it's all raised to the 6th power. So an exponent to an exponent, you multiply. So keep your base and multiply. 30. There's your final answer. Okay? You can go ahead, pause the tape, and give some of those a try, and then start it back up and check your answers. Okay, you can take a look. I did 13 and 14. Let's talk through 15. So I'm just going to rewrite that one, a to the 4th times a to the 2nd to the 4th. And that's all divided by 2a to the 8th. So I would take what's inside those parentheses in the numerator and do that first. When you multiply, you add exponents. So we get a to the 6th, but it's still raised to the 4th power. And then the denominator, we haven't done anything with yet. 2a to the 8th stays as is. Now you have an exponent to an exponent, or a power to a power. So you multiply. So we get a to the 24th divided by 2a to the 8th. There's a 1 in front there. It's understood. Now you have like bases. What do you do with exponents when you divide? You subtract. So we leave the 1/2 alone. Sorry, I'm running out of space here a little bit. And we're left with a to the 16th. So 1/2 a to the 16th. Okay, I'm going to put up the answers for 16, 17, and 18. If you want to pause the tape, you absolutely can do that and work through those. So 16 is 6 to the 32nd. And please ask me questions in class if you don't understand where I got these answers from. X to the 6th. I would love to see your work. And 18 is 113 to the 6th times 37 to the 3rd times 51 to the 12th. Okay? Go ahead, flip the page, and we are almost done. So 19. Okay, Tim thinks that a to the 3rd to the 2nd is equal to a to the 5th. Is he correct? Power to a power. We just learned it. We multiply. Does 8 to the 6th equal 8 to the 5th? No way. Not equal. Okay. You could write yourself that note. Power to a power. We multiply exponents. Okay. And last one, express the number, big number, okay, in exponential notation. So it's 10 to what power? How do we decide what power? Count up all those zeros. So we should end up with 11 zeros, 10 to the 11th. Okay? And then it says, how many times bigger is your answer from part A than 10 to the 5th? So we have 10 to the 11th and 10 to the 5th. It's 10 to the 6th bigger. How did we get that? Okay, 6 and 5, 6 plus 5, multiplying, adds up to 11.